couple times. This is nothing new. We did this a long time ago. We might need to go back to overleaf, but that is for another time. If we have to go to overleaf, then I will. Um, and if we're actually going to overleaf, then we're definitely going to change it. Yeah. Usually when I do matrices, you have to go to overleaf. Yeah, I might need to go to overleaf then. But that's like later on. And we need to talk about closure and other linear algebra variables because the way I taught you linear algebra is garbage, I will admit. But I will say the way that this taught is the way I showed you. So what we're going to do later on is basically later on we're just gonna not do it the way that I mentioned. What I mean by that is that we're gonna change it up in linear algebra. We're gonna make it less daunting. So, I mean more daunting, but less what's the right word? Memorization and more proof style on that one later. The reason I'm doing that is because I mean, for now, there's not really much proof I can give you on that one. But later on, there will be a bunch of proofs. You'll see what I mean later. There'll be a bunch of questions I can make up. But for now, we're gonna just say these are just basic like proof that this thing is like that. There's not really much I can say here. Then that's how it works. The difference. Oh, yeah. I mean, we're still in the station, but um, I'm questioning if we need to do all this. But yeah, I guess we do. Even minus odd equals on. Yeah. And some of these questions I will delete. This one I definitely think I can delete. I mean, it's kind of obvious that this is true. I mean, maybe I won't. We'll see. Um, yeah, this was made by me a long time ago, very long time ago. I haven't really changed it at all, which is my mistake. I will admit. At least tell me to delete this one. So you know what? I'll delete it. Do we really need all of this, like addition, subtraction, minus? Yeah, no. The difference between two odds. I'm literally spoon feeding them everything. Okay. I'm okay with spoon feeding everything because I'd rather have that than a class where I don't spoon feed everything. So I'll allow it. I'll allow it. Very much will allow. Um, am I spoon feeding you too much? Probably. Probably. Only because of a curve. Yeah, but only because of, yeah. Anyways, here's the truth. We have the difference of integers. We can do this one too. I'm getting bored of it. Really, I could delete half of this and think I'll be happier with the content I'm teaching in this section. But either way, we're done. Unless I forgot something. I was going to prove that integers well, adding another integer gets integer, but there's no point in doing that. There's a more bullshit proof. Basically, it's the definition of an integer is that two whole numbers with minus can equal that. Therefore, if you have added and make a whole number, and then there's difference, and those differences to get your whole number, then you have integer, and it's just a pain in the ass. I just rather not do that. Because then you have to realize to invoke whole numbers, and then whole numbers invokes natural numbers, and then it just becomes a pain in the ass. There's a point in time where you stop doing proofs. All right, and this question, do we really need it? Uh, I mean, even minus odd. We have not done a minus. The difference of odds we have, which is this, which gives you even somehow. That is true. Yeah. But we haven't done it with the difference of even. Should we and odd? I'm actually. I want to test this out. If I have 3 minus 2 that equals 1, 5 minus 2 equals, yeah, that always works. Very powerful thing, I guess. I have no idea why I would put this in here, but I would put this in here. Yeah, I'll put it in here. Honestly, what I should be doing is combining some of these less known like this. I should be combining them like this, like that, and deleting the extra space, making it more consistent. Yeah, I should be doing that instead. I don't know why I didn't think of that. Um, this way I can measure most of these shit up. Like if they're going too out of bound, then I can actually notify myself. Oh, I forgot to email professors. I need to start emailing some professors. Um, I'll be doing this after this video, honestly. Uh, I did make a mistake. Well, okay, even odd. Oh, yes, I did. I don't know what I did wrong, but fair enough. You cannot be bothered. The thing is, with enough of these proofs, you don't need to go any further. I mean, it's kind of self-explanatory that we're repeating the same thing like 300 times. So after a while, there's no need to do more of them. So I'm okay with stopping here, honestly. But yeah. Let's see how much more there is. Okay, we're good here. So difference of integers next. Do we really need that? I don't think so. Um, yeah. We could go further, yes, but the difference of even integers and odd integer is odd. Well, no, I mean, you can just do the same thing. There's no need for me to go through all this process again and again and again. So I'm actually going to delete this, hoping that one difference equation is enough. And then we can move on to the more fun stuff, more other non-one one page is enough. No more than 2 pages, 1 pages. We don't need more products. We have done multiple of these. Um, we should also write over here that this is yeah. Square of evens, right? It's yeah, think about it. It's multiplying multiple evens basically, and we know that the even multiplied by even is an even. Therefore, this is gonna be an even. Yeah, we should write that down. Okay, this is interesting, but this is not proof, although I will say. I'll add extra information here. Uh, Move an even to the square. And, yeah, and show the following. The reason it looks like a different text is because I actually did this in LaTeX before, which is yeah, a pain in the ass. It was less pain in the ass than some of them, but yeah, there we go. Wait, that should do the trick. Yeah. So in reality, there's multiple ways to prove it, and I only showed one, and I'm fine with only showing one, honestly. You could also prove it even by saying even plus even is even because multiplication is just multiple addition of numbers. In this case, a lot of even numbers. Yes. So and same with the square of odds is adding a lot of odd numbers, which means this is going to be odd. And we're just going to copy this to over here. Oh, we have to make a new insert, new drawing, and yeah, odd square is odd. No, it's odd. Pretty sure it's odd. The thing about this is that it has to be divisible by 2, right? But in reality, if you think of two odd numbers, 3 squared equals 9, 5 squared equals 25. You know, it's a beautiful concept actually. I mean, granting deleting the maybe I should have left in the even ones because there's some cool properties of it that you can infer from it. Okay, I'm just gonna do something real quick because I regret doing that. What I did to the previous one. So we're just gonna um, okay. Think here was it still exists, right? the minus odds, yes. Okay, so now I can just delete this, delete this, and then put this in here. Okay, so now I can, the product of two integers is odd. The product of two integer is even. Wait, what did I fucking do? Okay, I think let's delete that. Product of two evens is even. Okay, we did that. So yeah, we're gonna use this. We will show that soon. Okay. No, what's cool about this is that it shows a lot about the numbers and properties of numbers. Not really mind-boggling, honestly, but it's something that's worth looking into. And similar to this, this is true. Excuse me. Am I a bad student? Depends on the class. If you're talking about linear algebra, then maybe. Yes, if you're talking about some kind of linear algebra, probably maybe. Yeah. So plus odd. I believe that's even, although. Yes. So this is wrong, but it's correct. How does this work? Oh, I think it's a product. Where's odd times odd? No, it's even. Huh? Something is not right because I see clearly the square, but 3 times 3 equals 9. But I wrote here that the product of odds is an even. No, that's a difference. Oh, sorry, that's the product of odds. Product of odds is odds. Okay, so it's a product. I was stupid. But product is addition at the end of the day, multiple addition. But the odd, okay, so I'm wrong here. I'm wrong here. Is realize that the product, even x product is even, even x odd is odd. My apologies. Um, yeah, and then you get the same idea over here, and you're good. You're good. You're basically golden after that. And I should put down that this is odd because um, uh, square is just uh, multiplication of numbers because square multiple multiplication of numbers. And yes, so with this you can really prove a bunch of shit. But yeah, it's a QED now. Yeah, you can see that M over here is just odd. I was really wondering what's going on with that, but no, yeah, I made a mistake. It's a multiplication. Because now think about it, a square something is just a multiplication of it, like multiplication by itself, which yeah makes sense now. Now, now k, like if this k equals 1, 1 plus 2 equals 2. So yes, it's always another thing to note is because this over here has a divide by 2, I was a little bit worried. But if you think about it, k equal 1, then we have 2 and then 1, so it's 2. So it's always going to be divisible by 2 because of this plus 2 and this. So the k can be, if the k is divisible by 2, then that's safe over here. But if it's not, like if it's odd, there's a k plus 1, so it's divisible by 2 again. Very cool. Yeah, so we're fine. We have even minus odd. We're gonna make this anymore. Squaring of even, I mean, we already did that. The product of an even and odd is even. Cool, but why would I need that? Cool, yes. Yeah, I guess it's cool to just know it off the hand off the breaks. Like, we'll make it because why not? I mean, insert new drawing, not drive. Prove even minus odd. Yeah, you can see I made this a long time ago. I don't even know when I made it or how I made it. It's such a long time ago, I don't remember. That's why I have to relook at everything. So I don't remember this shit anymore. How I even made this. Like, oh, um, equal odd. There you go. Prove that. Minus. There you go. QED done. Product of two integers, which is 2k integers and odd is even. I mean, do we need that? Even in odd multiplication will get you that. But surely you don't need it. Even in odd, how would that? Well, I don't really have a question for that, so yeah, okay. Yeah, I don't care. Yeah, why not just delete it? There's no point in having that in there. Yeah, I think these are good enough. Yeah, I should put a black box between all of them, but I could care less about that. It's less important than any of the other ones. But yeah, you could have proven even in by realizing that even times even is even because square is just multiplication. Yeah. Now we need to talk about absolute value. Um, yeah, I like this better. Yeah, so here's what's happening. Absolute value a lot of times are getting rid of direction. We talked about negative being another way to add direction. So magnitude, the way they teach it, is absolute value get rid of direction, one way or another, and that's why higher absolute value, or what otherwise known as a norm, and this I will explain it as a norm of two in reality because that's how they write it. The norm of two, which is insert equation. If you don't know what a norm is, we're about to explain a new equation. About what a norm is. A norm is a summation. Um, n equal 1 to, in this case, 2. So it's index I, sorry, I. And then the n equals 2. There's two of them. And I believe it's the absolute value of square of x underscore I. In reality, that doesn't matter because you're squaring it, so you can just get rid of the absolute value. But and then you square root it. Yeah, I knew that's gonna happen. Just make this smaller. Doesn't matter. We'll explain it later, anyways. I would double check this. Actually, I need to double check this just to make sure I'm correct. But I'm pretty sure that's the norm of two. If you want to double check it, do it yourself. Um, go to Wikipedia and just go to norms, and then you can check out all the special norms of it. I'm pretty sure I am correct that this is a second norm. If I'm wrong, then I'm wrong. Yeah, I don't want to be wrong, so I might double check on my phone right now. But yeah, I'm pretty sure I'm right. I'm pretty sure that's the second one. I'm just gonna assume I'm right because I'm pretty sure I'm right. Yeah, the proof by QED. QED is like a way to say, yeah, shut up. I know, but proof by intimidation. Yeah, whatever. Uh, Never gonna not know this. Okay, so this question becomes this is this is just a solve question. This is nothing new. I mean, yeah. So then we just solve. You just solve it. You just solve it. There's nothing special about it. You just solve this and you're good. You're good. You just go to yeah. You just solve it and you're good. Yeah. Yeah. Do I care about the expanding thing? Expand later in the book. Yeah. Okay. Fair enough. No, I'm just gonna delete this because there's no point to dash pound the topic even more. So yeah, whatever. Um, I don't like how this is set up. Yeah. Let me just. This time it's a solve proof. Okay. But this is gonna be proof by intimidation again. In reality. It's not really a good proof. It's just proof by intimidation. Like, hey, prove me wrong. Yeah, this is proof one of those proofs. I mean, we all know them. I mean, now I know them. They you didn't know what they were to took that class, so didn't know what that meant. But it's basically yeah, I intimidate you, and I know for a fact you're not gonna shut up. Therefore, yeah, yeah. One day I might show off my transcript. You're gonna be shocked how many C's and B's I have. Uh, um, Yeah, I'm a dumbass in reality a lot of times. Half the times I have a dumbass class. I'm a dumbass in the class. Delete row. But yeah, by doing that, we have secured this question, basically. Um, QED. Uh, yeah, proof intimidation. Yeah. Yeah, I like that. I like that I'm already putting this norm here, that this is second norm. It's before that I did not know what the norm was, so whatever. In reality, you should be doing double this, but that looks so ugly that I don't want to do that. I'm not going to do that because it looks shit with the equation. I'm not going to go to fucking overleaf yet. I know how to do overleaf, I promise you, but I'm just lazy about it. Prove that the first solution to consecutive odd integers is the proof of four. Um, yeah, why is this down here when it should be up over here? What? Okay, I mean, sure. Sure, dude. Sure. Yeah, as you can see, I'm just gonna do this. Okay, how does this align with the absolute value? I'm gonna make this question absolute value proof. I don't know how I'm gonna do that. Prove that the solution of two consecutive integers divided by four, sum of two absolute. It shouldn't change anything. Into absolute any two. Prove that the sum of two absolute two consecutive odd numbers. Yeah. So, but what we're gonna do. Two numbers are considered consecutive when this happens. So now I did absolute because we have to get to the theme of this thing, even though it won't change anything if I remember correctly. Um, Let me check if this statement is still two. If I change it to absolute value, like 2n plus 1 absolute 2. Uh, I'm doing a pen and paper if you don't realize what I'm doing. I genuinely think it is something's wrong. Let me check. So the summation of two integers, I just had to figure out one counterproof that would dissolve this. Which is what is this proof of two absolute two? So it has to be like consecutive. I think this is wrong. Uh, isn't it 2n plus 1, two consecutive odd integers? Yeah, that makes sense. Okay, 2n plus 3 absolute value, and then what is it? If you add them up, you get and then divided by 4 is still an integer. And usually I just say n equals, yeah, okay, that equals 4 equals 1. N equals 1. Um, 0, whatever one that is. 1, just 1, 2 plus. Ah, here it is. Okay, so it doesn't work. It is falsely impossible. Because the absolute value causes problems. If I do absolute value, it is so this is gonna be wrong. How do I now show this off? Just counterproof. You just have to give one example. Um, but I do like this question when it does work. Okay, I'm looking at this and saying divide by 4. So n equals -1. The -1 it is -2, so it's -1 is 1. And then -2, 1 plus 1, so it's 2. I get half, so it's wrong. So okay, false. That this statement is not true. And then we will yeah, well, this is the first one that's not true. So we're making it bold. The statement is not true. False. This proof is not true. Um, and then how we prove it? This, which if you add them up, and then divide by 4 equals integer. All right. Sorry about that. Anyways, this is how you prove it. if this equals z, if this is contained in z, I believe it's I'm not sure if there is this how do I write this in map notation? This is called there is this something there is this. So in in this equation there is this a number. You know what? I'll figure this out if any, but I don't think I need to do some fancy language for this. Um yeah. Instead, we're gonna do I already forgot. Comma n equal -1. This will tell you everything, which will get you n equals -1 divided by 2. Hmm, like this, which is not an integer, therefore, well. So this shows when n is equal 1, that's 1, and then 2. Wait, I think I did this wrong. No, I did not. Did I? Yeah, I think I did. Let me double check. And -1, -2, uh -2 plus 1 equals -1, and then -2 plus 3 equals 1, 1, 1, 1 plus 1 is that's a half. And there's no negative because it's absolute. Yeah, anyway, that's an easy proof there. I won't be doing a lot of proofs that are false, just due to a lot of times I just want a correct proof. So I'm not making a deal. Therefore we're good. Yeah, I did not expect me to change that up, but absolute value. I mean, we should. By the way, to be clear, if it was an absolute value, it is divisible by 4. Uh, yeah. Why I'm doing that is because the theme was absolute values, and I went off to regular integers again, and that doesn't make sense. We're doing this statement is not true. We're gonna go back to regular integers, like yeah. So there's the norm. Um, yeah, we're good. You find that a and b be integers with both of them non-zero. We call these integers d in common. Oh, right, this stuff. Yeah, we're definitely gonna fix this. Um, yeah, okay, all right. Yeah, I'm gonna fix this real quick. Don't worry about it. Yeah, I don't like how I should close either. Okay, what we're doing. Oh, I hate this. Okay, we'll fix this later. And I need to edit this to get rid of that voice. But we're definitely not doing this shit. This shit looks ugly. We're definitely just gonna change it to divide by a because it's much easier in the eye. Uh, I like how I set it up. No, I don't. I haven't been doing a lot of definitions, honestly, and I couldn't care less. Oh, no, this is pointless. So now we can bring this up. We can do it like this. And anyways, we're continuing here. Was I recording originally? I don't know. But anyway, as long as we're recording, we're good. Alright, fix that portion. I'm gonna leave it like this. That's fine. How are we? Okay, yeah, we're changing things, but we're almost done with the baby steps, so yeah, let's be happy about that. What am I writing here? Yeah, sure, that's fine. I mean, it's not like it's gonna cause any problems. Request it. Yeah, request it. Not really that hard. Yes, yeah, that's what it's called. Let's prove the relationship between this. Yeah. I mean, it's not really. Okay, we're done here. It's gonna be an hour long, isn't it? Yeah, it's only an hour. Let's not do this ever again. I changed my mind. Having to showing what I do here is not the best thing.